So we'll start again with the baseline predictor. And the first step in computing the baseline predictor is to find the raw average, or the mean, of all the elements in the training set. So if we look at the elements in the training set and add them up, we're going to get 4 plus 5 plus 3 plus 4 plus 3, and so on, divided by 22, since there's 22 elements. And it turns out that if you add up the elements in the top there, it's going to come out to be 88. So we're going to get 88 over 22, which happens to come out to an even 4. So the mean, the raw mean of the training set is 4. And so that's higher. That's a high value. So the set itself is already biased to a higher value. And then now we can actually compute the biases for each of these users in each of these movies. As we said before, the bias is the mean in the rows columns minus the overall or raw mean of the training set. And so, for instance, if we look at user D, we could look across user D, and remember we're only going to consider the values that are in the training set. So there's only 3 of those: this 4, and this 5. So the bias is equal to 4 plus 4 plus 5 divided by 3 minus the mean, because we want to do it relative to the raw mean of 4. And so that comes out to be 13 over 3 minus 4, which is 0.333. So user D tends to rate movies higher than average, which makes sense because we have one 5 here, and the other 2 are 4s, which is the same as the mean. And for instance, then we can maybe look at the bias of movie 3. So the bias of 3 is equal to, so we have 5, 3, 4, 5, and 5 here. So we have 5 ratings. So if we take 5 plus 3 plus 4 plus 5 plus 5, divide that by 5, and then subtract out the mean of 4, we're going to get 22 over 5 minus 4, which is again positive, and we get 0.4. So movie 3 tends to be rated higher than average as well, which makes sense because a lot of its ratings are 5s, and the only 3 it has occurs one time. And so we can similarly make the computations for the other users in movies, and we come up with the bias values shown in the table over here. And these bias values make sense, and we can look at them for a second and interpret them. For instance, we see user A definitely tends to give high ratings. So A gave 2 5s and 2 4s, which is average, so he's definitely above average, and it makes sense that he would be higher than 0. On the other hand, user C tends to give low ratings, and that's why he has a negative 0.6. So you see a lot of his ratings are below the average of 4. Only one of them goes above to 5. Movie 5, if we look at movie 5 here, 5 is very positive, 0.6, and it does tend to receive high ratings. So most of these are higher than average, movie 5. And at the same time, movie 2 tends to receive pretty low ratings, so it's kind of maybe a poor quality movie, or it's received low by critics, because you have 3, 2, and 2 here in the training set. And so that's how it can sort of make sense. And in fact, F has no bias at all. So the average of F is the same as the raw average. And so if you remember the equation for the baseline predictor for a given user and movie, it's just going to be the mean plus the bias of the user plus the bias of the movie. And so we can apply that equation to come up with the baseline predictor for all the elements. And the results are shown in the table at the right-hand side over here. Maybe we can run through one of those computations. Let's try for user 3 and movie D. So the mean is 4. And the bias we just saw for user D is 0.33. And the bias for movie 3 is 0.4. So we add 0.33 and we add 0.4 to that, plus 0.33 plus 0.4 is going to give us 4.7, and that gives us exactly this value for user D in movie 3. And we've denoted the elements that we don't actually have, so the ones that we don't have any reference for, in quotation marks over here. These are the unknown data elements. And then again, the test data is denoted in red. And once more, we have to remember that we're going to clip any values that come up to be greater than 5. And it turns out that A5 over here would have been greater than 5. And we can note that by going back to this data and looking at the bias of A being 0.5 and the bias of movie 5 being 0.6. So if we take that initial rating of 5 and we add 1.1 to that, we're going to get something that's much higher. So then we want to take the RMSE of this data, and we'll illustrate that for the test set as we did last time. And so we want to take the square root of the sum of the squared errors. And so if we start looking at the differences between the training set 4, 5, 3, and 4 and the values over here, we're going to get the square root of 4 minus 3.667 squared plus 5 minus 4 squared plus 3 minus 2.667 squared plus 4 minus 4.650 squared. And we want to divide that whole sum by 4 because we have 4 elements. And that's going to be equal to the square root of 0.1109 for this first term right here, plus 1, plus 0.1109 again, since these are the same away from each other, plus 0.4225 divided by 4, and that is going to give us 0.641. And in the same manner, we can compute the RMSE on the training set to be 0.607. So that would be for the training set, whereas this is for the test set.